Yeah. All right, I think we'll get started.
Thanks, Ellie.
Pretty much everyone's here now. So yeah, so today we're going to learn how to use the Blanca supercomputing cluster. Oops. I need to click on this. Oops, okay. And so we're going to go through a few of these things, just how the cluster is set up generally, how to get onto it, what Slurm is and how to use it, then a little bit about the data management that the cluster uses, and then how to use the actual software to do your cryo-EM or cryo-2, whatever you're up to. And then we'll go through a few practical examples, and then I've just got a summary workflow to help you stay oriented. And a couple weeks ago, Sashi, Nate, and I actually went to launch of Alpine, which is the newest supercomputer, but Blanca's housed in the same place. And so we got to see it too. And so essentially it's just big racks of servers in a super air-conditioned environment. But it's pretty cool if you get a chance to go see it sometime. So yeah, so to start, what is this cluster? How does it work? And so CURC, so the research computing arm of the university, has these three supercomputing clusters, Summit, Blanca, and Alpine. So Summit is the older one. They're starting to phase out. Still got a lot of resources, but most of them are getting kind of old these days. Alpine's the brand new one. It's got a whole bunch of new fancy stuff, and they're still kind of bringing that online. And then Blanca's the one we're going to use. And so Blanca is what's called, oh, I guess I'll get to it in a bit, but Blanca's the third one, and you kind of have to buy a node or a computer to put into this server, and then you get access to it, the whole cluster. And so common to those three clusters is this other set of computing resources that include the login nodes, the viz nodes, and then the compile nodes. And so then the rest of these nodes, and right here, are just all of the compute nodes that are on the RC environment. And so we'll explore this schematic a little bit later too. So kind of the first part that we may kind of just sidestep altogether, but it's important to know about are the login nodes. So these are the nodes that you can first go to in the cluster, and this will send you to whichever cluster you want or allocate resources. You can submit jobs from there. And these are used just for submitting jobs or editing scripts. You can also move data around on them, but they're not really made for computing on them. So everyone logs into these nodes, sends off jobs to whichever cluster they want, and then gets off of these nodes. So if you're on this node, don't do any computing. And it's very hard to because they're not generally set up to do computing. So it's generally not too much of a problem. And then those are common to all. Yeah. And so there are, you probably won't ever need to know this, but if you have like a persistent job running on one of them, which you might get to in the future, you'll need to know that there are 4 of these nodes. So 10, 11, 12, and 13. I don't know why they named them up in the 10s, but they did. And generally, you'll just say, I want to go to a login node, and it'll just send you to the one that has the least traffic. But if you have a persistent job running on one of them, you need to log into that specific one to get back to it. But we probably won't ever need to do that. It's just if you ever do, it's a good thing to look at. So these ones are going to be more what we're going to be using. So the viz nodes. So these are GPU accelerated nodes. There's 2 of them, viz1 and viz2. And they're for rendering graphics. But what we're going to do is log into these viz nodes to get onto the cluster. And I'll show you why we're going to do that in a second. And actually, these are pretty decent computers by themselves, even though they're just used for rendering graphics. And research computing says that if you want, you can also use these clusters to compute on if you really need to, but we probably won't do much of that either. I don't think they can be used to submit jobs too much, but again, they're common to all the different clusters. And then so the actual meat of Blanca are these condo clusters. So essentially, Blanca is broken up into these different, they're not actually different server racks, but you can think of them as different server racks where a specific entity like CURC, so research computing, will have a partition, and they'll stack all of their nodes in one, and then whenever they submit a job to their partition, it'll go to one of these nodes. And there are a couple of different people. We have one that has 3 nodes in it, so if you submit a job just to BioKEM generally, it'll go to one of these nodes. Otherwise, you can submit just to Blanca generally, and it'll go to any of these nodes. And then there are a few people that just have like one node, and then there are a bunch of empty slots that can be used for other nodes to expand to in the future. And so right now, we have 3 nodes that consist of about 9 high-end GPUs, a bunch of CPUs, a bunch of RAM. So they're all pretty good computing resources. And the one difference between submitting to our partition versus the whole cluster is that we get priority on our partition. So if someone else is running a job that's not one of us, they can still run a job on our cluster. But if we submit a job, it'll start over their job, and their job will be requeued somewhere else when resources are available. And so it's a pretty efficient way to do it. The other advantage of submitting to our queue is that instead of a 24-hour day limit, or 24-hour limit, which is generally sufficient for most jobs, we can have a 7-day time limit, which is probably excessive for almost any job you're ever going to run. But you can do it on our nodes. So then if you submit to the rest of the cluster, so any of the other nodes, and this is just like a subsample of the nodes, there are a bunch more, you can have access to different types of GPUs, different CPUs, just more resources in general. And when you submit to one of those other places on the cluster, your job can be preempted, which just means that if someone who actually owns those nodes wants to run their job will run over your job, and then your job will get put somewhere else. And generally, it'll just requeue and you won't even notice. So it's not really a big problem. And this is a good way to run if you need to run like a lot of jobs, or there's a huge queue time on our part of the cluster. And then whenever you're submitting, just generally, you have a 24-hour time limit. And usually that's plenty for most of the resources we're using. Yeah. So the last part of the cluster that we're going to talk about anyway is this compile node. So if you're ever installing software on your own user, you generally want to either use one of these compile nodes or go to one of our nodes or another compute node because you don't want to compile software on the login nodes. That's just a little aside there. So now we're actually going to try to log on. So if you go to that email I sent you, there should be this link to the Open On Demand website. And I think I'm still sharing my screen. Yeah. So if you go to Open On Demand, and I've got it bookmarked here, it's probably a good idea to bookmark it if you're going to go to a lot. You can just enter your credentials in. So these are just your CU login credentials. And so if you've created your RC account, which I think most of you had by this point, that will take you to this page. And so research computing, because this is not on a secure network, like most other ways to get into research computing, they'll use dual authentication instead of using a secure network. And so if you set up your account correctly and set up the dual authentication app, so the Duo app, you can just send yourself a push and then you'll get a notification on your phone that will ask you whether you want to log in or not. And if you do, just click approve, and then it'll log you in to this website. Was everyone able to do that? Yeah. Cool. Nice. All right. And so this is how we're going to interface with the cluster, essentially. And if we go up here to this interactive session, there's a bunch of stuff to explore on this page, but the thing we're going to focus on is this interactive sessions page. And so yours probably doesn't have anything on the right side here. I've been opening up interactive sessions all morning. But if you click on this core desktop app, you'll get to this page. And so I'm not sure what the default settings are anymore. But essentially what this is going to do is create a remote desktop on one of those Viz nodes that I talked about earlier. And so you can set it up for how many ever hours you want. I think the limit's probably 24. And it's generally as long as you'd ever need to set this up for anyway. You can go 8, and then you can set the number of cores. And again, this is probably not going to be super intense of a thing. If you're actually trying to compute on this node or something, you can set up more cores if you want to actually do something, but 1 or 2 is probably fine for most applications. So then you can click launch and it'll bring you out here. It'll take a few seconds for the job to start and to give you a connection window. So it gives you this message that just says your job is being queued. And then once it's queued, you'll get these little sliders in this launch core desktop app. These sliders just deal with like compression and image quality. You probably never need to change them. If you really want to, you can. I don't think it's really going to matter that much. But then you can click launch core desktop. And so this will bring you into the remote desktop of Blanca. Is everyone able to get here? Oh, yeah. There were 3 people that might not have access because they didn't quite get to the last 3 people on Friday, but just follow along. But which one? So if you go back to, to here, if you just press launch core desktop, did you get that button? To spawn a new
Shawn.
desktop. What?
Shawn, I got an error when I did that.
What was your error?
It says SPatch error, batch job submission failed, invalid account. So am I one of the people who wasn't set up?
You might be, yeah.
Okay, never
So
mind.
we'll fix that, but just follow along for now. But
Okay, thanks.
I had that. I went through this all last week. I got
Okay.
that message a bunch,
Huh.
and I think you probably have to go to research computing, just do the RC help, and then they had to do something with kind of like add me to a group or a certain login credentials or something. So I bet they can help pretty quick.
Yeah, I had them add everyone to it, but they might have messed up. I'll make sure they add everyone to it. But
Okay,
did
thanks.
everyone else get that error? What, like SBatch submission? Yeah, no.
I did, I got that.
Okay, all right. Some people might have got it. I'll email them and ask them to make sure they fix that. Okay, but you should be able to follow along. It's all on the slides too. But for everybody else, you should be at a screen like this. And so this is actually a remote desktop on one of those FizzNode computers. And so from here, what I'm mostly going to do is just click on this terminal icon. And so this will bring up a terminal within the FizzNode cluster. And so from here, let me check my notes. So we've spawned a job, launched the job. Okay. And so the next thing we need to do, and this will only need to be done this one time, the very first time you log on, is to set up the different BioKEM environmental variables that I've set for you. And so if you go back to the email I sent out this morning, there's this command here. You'll just want to copy this command and then copying it into this. Yeah. Sure. Oh, really? Okay. I think I put in that, but okay. Cool. Okay. So you can copy that there. And then copying into this window, because it's actually a window on the other computer, is a little different. You have to go to this side tab and then this clipboard icon, and then paste it into here. And now it's going to be in your, and you can leave the spaces probably, but now it's going to be in the computer's clipboard. And so if you're on a Mac, you would normally press Control V at this point to paste. But because this is now a Linux computer, you need to press Control V instead of Command V. Or actually, that's not going to work either. Just go and right click and click paste. And so what this is going to do is set up a line in your startup script that will just automatically load this environmental variables file every time you log on. And then I can go in and add things, change things, whatever I need to do there. So
we have to go to our email in your system, so it won't- it's from my
So
computer.
you should be able to copy it from here on your computer.
Yeah, well, I went into my mail, copied it, but won't paste it.
Right.
Yeah,
So then you need to go into this little side tab here.
where is it there?
Yep, go to the clipboard and then paste it into this clipboard
Oh, okay, gotcha.
Yeah.
So,
and then right click in the terminal. And hopefully that command has been run. If it's still letting you type, just press enter and it should run the command. And then once you've done that, you just need to restart the terminal. So just exit it and restart the terminal.
Hey, Shawn.
Yep.
So will we need to do this like pretty much every time we kind of log back, like start a new node?
No, just the very first time. Yep.
Okay.
The very first time, and then you never have to do that again. And so now once you've done that, you should have access to a whole bunch of different variables and commands. And so the one that you're going to be using the most is just called BioKEM interactive, and you should be able to tab fill that. So if you just start typing BioKEM tab, and then there's a couple options, so you have to press the I after that. And then if you press that, what this is going to do is spawn an interactive job on one of our compute nodes. And it can take a little bit just to allocate resources. But then hopefully your terminal now says that you have one of the BioKEM computers. And so what this is going to do is just spawn a job with a single CPU and a small amount of RAM. So this isn't to do any computing. This is to launch GUIs so that you can then launch jobs from them. I'll show you another way that you can actually use this to compute directly from in a minute, but this is our first one here. So yeah, so what that command actually did was it took this sinteractive command that is local to clusters that creates interactive jobs on these compute nodes so that you can use the compute nodes from your terminal. And the one I've made, this BioKEM interactive job, is just to get to one of our specific nodes. And it does a couple other things that allow you to forward graphics and things, but you essentially don't need to know it. You can just use the command. And the other command you can use that's like that is called BioKEM custom. And so if you want to compute directly from your terminal instead of submitting a job, which I'll show you how to do later, you can give it two arguments. The first one is for number of CPUs, and then the second one is for number of GPUs. And be realistic with the number that you add there, because everyone else can use these resources too. And when you're using them, someone else can't. So be realistic with what you need to use there. And then the last two, there's also the Blanca equivalents. So if you don't need to have priority or a bunch of people are using our part of the cluster at the moment, you can submit these Blanca jobs instead, which will just go off to one of the other nodes in the cluster and allocate a job for you instead. And so those are useful sometimes. They can be preempted, so you could be using it and it might interrupt. But you can see how that works for you. So yeah, so so we did this. There's another way to log on. It's just in the slides here. I'm not going to go through it much, but if you want to log on, not through an interactive job, you can log on directly to one of the login nodes, and you can do that to submit jobs and things, but we probably won't go through that. So now we're going to talk about how to submit jobs to the cluster. And so the cluster is managed by something called Slurm, which is, I forget what the acronym actually stands for, but essentially—
John, it's simple Linux, Unix resource management, although the simple is no longer true.
Yeah. Yeah, but it's a great way to submit jobs. So because this is a common cluster and everyone shares resources, what this algorithm, it's actually running on a computer, does is you'll submit a job to this scheduler, and you'll tell it how much resources you want and what the job is that you're actually going to run. And then this controller or the scheduler will figure out where there are open resources, and when your job comes up, it'll shoot your job out to that node and start it and manage it for you and make sure it's running correctly. And you can also like use this to check the status of your job to see if it's failed for some reason, or if there are a bunch of other people that have submitted jobs, you can get to this thing, which is called the queue. And so if you just type the command back into your terminal, SQ, and you should be able to just tab fill that too, you'll get this whole list of things that are going on. And so these are just like, you've got the job ID here, which priority each job is running with, what the job's actually called, who's running it, if it's running, how long it's been running, how many nodes it's using, and then which specific nodes it's using. So there's a lot of information here, and generally it doesn't really benefit you to see what everyone's doing because you don't really care that much. And so if you want to see what just you're doing, you can type SQ-U, so -user, and then your identity. And so what this will do is just show you your jobs that are running, which is generally what you care about. And so you can see I've got 2 interactive jobs spawned, and you guys should have all 1 interactive job spawned or something. The other useful command here, and it's in the slides too, but is if you run SQ, then you can grep. So this is like a search command. You can look at all the BioKEM jobs that are running. And so you can see we've got a lot of people logged onto our nodes at the moment, running things and stuff. And so this might be more useful if you want to see if the nodes are being used a ton or not. And so that'll give you a good sense of that.
Hey, Shawn?
Yep.
One addition there, another way to do the same thing is SQ -P Blanca BioKEM.
Okay.
You don't need to do the grep. So -P means partition, and
Yep.
Blanca BioKEM is our partition.
It'll be like this. It's Blanca -BioKEM. Yeah. That one's just how they set it up, but yeah. Cool. And so, yeah. So usually when you're running a job, the best way to do it is to submit it to this Slurm manager, because that will make sure that it runs properly and make sure that we're all sharing resources really well. If you just start opening up interactive jobs everywhere, you might be using up resources that other people could use after your job ends and you're still using them or something. There are also some more advanced ways to use Slurm as well, where you can actually start the next job when your job finishes and stuff like that. Those are a little more advanced, but and then the other thing is sending it out to other nodes is really useful when you need more resources, and the Slurm manager will manage it to see if somebody else that owns those nodes preempts your job, it'll save your job, and then it'll requeue it on some other node once the resources become available. And so you don't have to do anything. And the other part is if a bunch of people are using our node and you submit a job to our node and it can't run, it'll just start when the other jobs finish. And so you don't have to be there waiting for it to open up or anything. You just submit it, go home, leave for the night, and then in the morning it'll have run and everybody's great. And so if you do submit to a different, just to Blanca generally, and your job's preempted, it'll be given like 2 minutes. This is just like technical stuff. It'll be given like 2 minutes to exit. So it'll be given 2 minutes to finish or just save in some state, and then it'll be requeued on some other node. And then we've got SQ. And then the other useful command here that you can use for Slurm is this scancel command. So if your job's running and you realize it ran into a problem, or you just want to stop it for some reason, you'll take this job ID here that you'll get whenever you submit a job. It'll give you this ID, or you can check it when you run this SQ command. And then just, you can type scancel and then this number, and it'll just cancel the job that you've been running. And then you can restart a new job or something. And you can only cancel your jobs. Research computing, if you've done something crazy that they think is harming the computers or something, they might cancel your job, but it generally won't happen. So, but other people can't cancel your job, only you can cancel your job. Cool. So that's the queue. And so a lot of the programs are going to use like rely on CryoSpark, iMod sometimes will try to submit this as batch. So this Slurm file for you so that you don't have to figure out how to write it and what the commands are and stuff. You can just press a button and it'll just do this all out of the head. But if you're running something that's more command line based and doesn't really have a good interactive GUI, you might have to write one of these files to submit to this Slurm queue yourself. And I've got some examples in our projects directory, which is found here. And again, these slides are all online. But essentially what it is are these lists of different resources and commands that you need to run. And they all start with this # sbatch flag essentially, and then the specific argument that you're trying to add to it. And so anything that you want to submit to the BioKEM partition, you'll need to specify with this partition equals Blanca BioKEM. And then this quality of service command is essentially whether it can be interrupted or not. And so you'd either use preemptible if you're submitting it to the Blanca cluster, or this Blanca BioKEM if you're submitting it to our cluster. And then the account is just always the same. It's just Blanca BioKEM. That really is just for like keeping track of, I don't know, stuff. And then you put a job name in there, the number of nodes you want to allocate. This is how you allocate GPUs. So if you want to allocate a certain number of GPUs, you can do that. This n tasks is the number of CPUs that you want. And then the amount of memory, the time limit, which is again, 7 days for our partition, or 24 hours for the rest of the cluster. And then these last two, you shouldn't need to change at all. They're just these output and error files. So every time you run one of these jobs, it'll make these two files if something has happened. So either the output that you would see in the command line, if you had run it in command line form, will be put in this file. And the error, if your job runs into a problem, it'll put in this error file. And so these are useful to check when your job doesn't run correctly, or you need some kind of output that just wasn't outputted in the normal file that your job would normally make. And so these are set up in folders that startup command already made for you, or should already make for you. And then you can just look in there and you'll just look for the job ID. So this slurm underscore, and then the job ID that you recorded. And it's usually just the highest number one, the most recent one. And then there are two examples here of actual sbatch scripts that I've run before. So I think this one was for a molecular dynamic simulation where I was able to request a GPU and then a lot of memory. And I just ran this on one of our nodes. And then this one over here, oh, these are both run on our nodes. Oh no, these, yeah. And this one over here was just one where I ran a bunch of commands to. And so this is how these sbatch files will kind of look. If you have a program to load, you can load the program, set any variables you need, and then actually run the commands you want. The other thing to remember is that when you, and this might not, the nuance of this might be lost right now, but from the environment you submit your sbatch script or the Slurm management file from, that's the one that it'll run as. So we're going to open up the SP grid environment later. If you submit a script from that environment, it'll run as if it was in that environment, which can be helpful sometimes. But essentially, if you already had all the modules loaded, you wouldn't need to load them again in this script. But it's always, if you're going to load modules, it's always good to load them in these scripts too. But when we're submitting stuff through this SP grid environment, the environmental variables you have in that environment will pass through to this script. So that's good to help. But again, any Reliant or like CryoSpark will submit these scripts for you, and you won't even have to deal with them. Yeah.
And with Reliant and CryoSpark, it's automatically submitting things like
Mhm.
there's no way to control that.
Yeah. Yep. Yeah, in the GUI, it'll ask you what you want to submit.
And then it creates the S script.
Right. And so what that GUI is going to do is just create this script and then run it. So that's all it's doing. And usually it saves those scripts somewhere. So if you want to like look at what it did, you can usually find those scripts too. Yeah, you could do that. We probably won't need to load any modules ever if we're just using the SP Grid environment though, because it's got all the stuff already there. So it should be really easy. You shouldn't really have to deal with loading modules or anything, but sometimes you might, yeah. Or if you want to use a program that's not an SP Grid that Research Computing has installed or someone else has installed. Cool. And so there's also a way to, within these scripts, allocate specific resources. So there are certain programs that will need to run on a really advanced GPU. So like the newest GPU ever. And there's a way to allocate those specific resources. So if you use this command, sinfo-output, and this will just tell you the node name and then what the GPU is here. And so I don't think I can copy that, but if we run that command in our environment here, we can see that these different nodes have these different GPUs with the different numbers of GPUs they have. And so this can be useful if you need to run specific programs on specific hardware. You may not have to deal with this ever, but if you need to run on like an A100 or something, this is how you do that. And you should be able to, in those GUIs where you say the number of GPUs I want is 1, you should be able to just use this same type of terminology. So instead of just the number 1, you'd say colon A100 1. So like this or 2. And then that would allocate those certain resources for you. And this is a good way to run if you like just submit to the Blanca cluster and you want to run on the fastest GPUs you can. You can just submit to those and it'll run on a node that has those very, very well. And then again, it's not going to start if you request more than are actually possible on a node or something. So cool. And then this sinfo command can also be used to check the status of different nodes on the cluster. So we can see here that the BioKEM nodes are all in a mixed state, which means that some of them are idle, some of them are being used, stuff's going on. These allocated ones means that someone has allocated the whole node for some reason. You'll see there are different nodes like idle. Sometimes you'll get what's called a drain state, which means either someone has submitted a job that created a problem on the node or something broke on the node or something. And so it'll complete all the jobs that are currently running and then the node will restart. So you won't be able to submit new jobs to that node until it restarts. But right now it doesn't look like anything's in that. But this is a good way to like, if your job's not running for some reason, you can kind of check to see if maybe the node is down for some reason or something. But generally they're pretty good about fixing them right away. Cool. So that was that. And then this is just kind of like some general guidelines if you want to know, should I submit to our partition or should I submit to the whole cluster? You can submit to either one whenever you want. But this is generally what I do if I can't split the job into less than 24-hour chunks. I'll always use the BioKEM node, or if I just want it to run quickly, I'll use the BioKEM partition. If I'm going to run a ton of stuff, like submit hundreds of jobs or something, then I'll just submit to the Blanca cluster. Or if it's something like a molecular genomics simulation, that'll take weeks, but I really don't care where it's running, I'll submit that to the Blanca cluster too, and just like chain together jobs or something. So yeah. So then we get to the data management part of this. And so on these clusters and specifically Blanca, there are kind of these 5 different places to store your data. And so the first one is your home directory. So this is just going to be the first place you're launched into when you start a job is your home directory. And in your own computers, this might be really large. You might store data here or something. On this cluster, it's only 2 gigabytes. It's not meant to store data. It's meant to store like configuration files, maybe some submission scripts, but it's not meant to store data. And then this, as with any of the 3 partitions here on the left side of the screen, they're all backed up very frequently. I think it's every 6 hours or something. And they can be found in these .snapshot files or .snapshot directories. And so this is a hidden directory within each of these different file systems that it'll save a snapshot of your work every, I think it's 6 hours. And then it'll like save a day and then a week. And I think it goes up to like 2 weeks or something. So normally in Linux, if you delete something, it's gone. You can sometimes recover stuff from these snapshot directories, but don't rely on it. But if you really do lose something, you can try to get it back in one of these snapshot directories. So then the second place to store stuff is in this projects directory. And so everyone should have a projects directory. The BioKEM facility as a whole also has a projects directory as well. And in that, I've stored some different data, different scripts and stuff. You should be able to see most of the stuff in there, but you won't be able to edit anything I've put in there. But on your own, you've got 250 gigs per person in this. So this is a decent size where you could store some data sets if you wanted. And this is kind of a good place to like share it with somebody else if they're not in your group for some reason. You kind of put it here. And a lot of people can see this. And this is also a good place to store software if you're going to compile your own software. This is kind of a good place for it. 250 gigs is usually enough to put your software in. Yeah, and then the last one of these on the left side here is the PETA library. And so most of your labs should have a PETA library allocation. And so this is just like you pay per terabyte per year. And I think it's somewhere around like $45 per terabyte a year, just pretty good price. And this is super backed up, super redundant, super fast. It's a great resource. You can allocate a ton of it. And yeah, so this is where you should store all of your data that you wanna keep safe. And this is also backed up. And so this one can actually, the backing up of your allocation actually eats into your allocation a little bit. So you may never be able to get the whole amount of data you've allocated. There'll always be some of it reserved for these snapshots, which is good because if you delete it, it could still be there. Yeah, and you can compute right from here. You can keep your intermediate files here. That can be a good way to do it. And that's generally what I do. There are also these other 2 Scratch directories, which a Scratch directory is just a place where you can do computing, compile a whole bunch of intermediate files, and then just bring the outputs back into some file system that you actually want to keep it at. And so this RC Scratch directory, I've aliased for all of you as just Scratch. You can just type Scratch and get there. And it's about 10 terabytes per person. I don't think the limit's actually enforced, but this isn't backed up and everything on there is purged after 90 days. So this is where you want to do like your computation and then move your data back to PETA library or something. Conversely, if you have enough space on PETA library, you can just compute right from PETA library. But if you have a bunch of intermediate files, this can be a good place to do it. And then just remember that you need to move it every 90 days.
Just a minor comment. On the PETA library, active storage,
Mhm.
the location of the snapshots is actually in .zfs/snapshot.
Oh, is it? Okay.
They didn't do an alias.
Oh, okay. All right. Yeah, it's all in their documentation too, the CU's documentation, but that's a good point. Oh, the other thing to say about PETA library too, is so I've listed the active partition here, which is what I always use. There's also something called an archive partition. So the difference between them is that the active partition is actually hard drives. in like a RAID format. And so it's pretty fast. And you can move stuff in and out really quickly. And it's great. The archive one is actually magnetic tape. And so when you put something there, it's really hard to get it back out because it takes forever. So if you're going to use archive for like putting your raw files or something in, if you really wanted to save them for like a decade or something, or really long-term storage, you could put that in the archive directory. And so you'll need to allocate that space as well. But that's not going to be high input output. So you don't want to, you can't compute from that essentially. But if you wanted to store something for a really long time, you can put it in this archive directory. But yeah, again, you need to allocate that. And then the last kind of storage device is this per node storage. So each one of these nodes has something called a scratch directory on the specific node. And so it's located at this slurm scratch variable. And so some of the GUIs that will submit jobs and stuff have this already in it. If you're just like doing it interactively, that's where you'll find this. And these are variable in size because they come with the node. Some of the nodes have like 10 terabytes of scratch directories. Some of them have like 500 gigs. It's usually quite a bit, but it can vary. And so this is local to each node. And then it's the file that you can save to is created only when you've submitted the job. So it'll be just the job. What this alias is going to is just the job ID essentially for each of these. And then as soon as your job is completed, that directory is deleted. And so yeah, so it can be good. For instance, like CryoSpark will cache particles on solid state drives like this. And so that's what it's good for. It's just these really super intermediate files that are made, computed on, and then deleted right away. So you don't ever save anything you want there, but your jobs might. Cool. And then just like general Linux things, moving stuff around, moving data around. They're just copy commands and move commands. I tend to use this rsync command a lot that will update your one file to match another file. And then you can also remove directories and stuff. But these are mostly just Linux things. If you're going to move something out of the research computing environment, so if you want to put it back on your computer or transfer it to somebody else's computer, you can do one of these rsync commands or do a secure copy protocol. And then the other part is they also have Globus set up for any data transfer that you want. And so how to do that is in that link there. It's pretty straightforward, but it's just essentially there's a Globus endpoint on research computing that you can send to wherever you want to go. I think they also have support for submitting stuff to an Amazon bucket, if that's your style. And then there are a couple other options and they can all be found on that page. But so yeah. So then how do we actually use software? Now that we've figured out where we're going to compute, where we're going to store data, how do we actually use the software? And so on any other node besides login nodes, because they don't want you to compute on them, if you want to use software that's computed or that's compiled by research computing, so not any of our SP grid stuff, which I'll get to in a moment, they have this software stack. And to see what they have, you can just type module avail. You can also just type ML avail if you want. That's the like shorthand for it. And then you can like scroll through and see all of the different, you can press enter to scroll through. Scroll through and see all of the stuff that they've got compiled. And then I can't go back up, but the other part is if you have something like in your personal, like if you've created a personal module, which is a bit beyond the scope of this, you can see the modules you've created. You should also all be able to see these modules. So these are just modules outside of SP Grid that we've created too, that will let you load these things. And, you know, essentially if you wanted to load one of those, you can just type module load or ML if you want to use the shorthand. And like if I wanted to load my build of Amber or something, I would type module load Amber, and now I would have, I think a command here is, I don't even know what a command is anymore. Yeah, but then you would have access to all of those commands and environmental variables are now in your path. And then to get rid of that, because it might conflict with another program you might have on, you can either module unload the specific module that you have. So it's going to unload that module, and now I no longer have it in my path. Or you can use the command module purge, which will get rid of every module you've loaded, and essentially make your environment fresh again. Not quite, but it can be. And then the other thing to note is that if you're going to compile your own software, you'll need to load the right compiler, and those are listed in the compilers. And some of these programs that RC has installed will only load if you load the right compiler. And to see which one you need, you can type the command module spider. And so what this will do is just run through all of the different things and tell you all about them and how to load them essentially. And then you can press Q to get out of that if you want. So that's good. Yeah, so that's how to load any of CU's loaded resources, or any that you've installed yourself as a module. And installing them as a module can be a little tricky, but yeah. So to use most of the software we're going to use, we're actually going to use this SB grid. So SB grid is just this software manager that essentially installs all of the cryo, tomography, X-ray, NMR, all of those types of programs, the open source ones at least, and manages them super nicely. And so once you've started an interactive job on one of the Blanca nodes, whether it's ours or someone else's, all you have to do is type SB grid, and it will launch the SB grid shell. So if we do that, it should launch this message that now says we're in the SB grid shell. And you can, I think you can like deactivate that message if you want, but it's a nice reminder that you've loaded into the right environment. And so something you'll see here is these variables that in this case, I've set up some of them that are personal, and then some of them that are site-wide configurations. And so what this is doing is telling the environment which version of each of these programs I want to use, because this SB grid actually is installing a ton of different versions of every one of these programs. And yeah, so I think it's taking like almost a terabyte of storage to just store all these software on it, because there's so many different titles and all the versions of each of those titles. And so right here, I've just set up the ones that I specifically want to use those versions of. If you don't set up one, it'll just use the default version, which is usually the like newest stable build. But for instance, like if you want to use Rely On, the default version is 3.1. But if you're into the Rely On 4 these days, you can set up your own personal one here. And I think we're going to go over, yeah. So get structure. So once you're in this, SB grid environment, then all you have to do to run one of the programs that you want to use is just use the normal executable you would to run the program. So in this case, if I want to just start Rely On, I can just type Rely On, and then we'll start the GUI in a few seconds. It'll probably ask me if this is actually a projects directory first. Oh, okay. And then you can just run these as normal. And this will, yeah. And so that'll work. If you want to change, versions of a specific application, so if you don't want to run the default version of Rely On, for instance, like I don't, you can see which versions are available by typing this command, sbgrid-info-L, this is an L, and then the name of the application. So sbgrid-info-L. And then you can see all of the installed versions. So there are a bunch of installed versions, so you can pick which one you want. And for various reasons, some of them might not work on our specific environment. So then you might want to switch to a different one or something. I think Reliant's pretty stable, but and then you can see that there are other available versions, although I think I have all of them installed anyway. But it'll also tell you what the default version is and which version you're actually using at the moment. And then if you want to change the version you're using, all you have to do is use this variable down here. So it's just the name of the program in capital letters, _x. The _x just denotes that it's a Linux program, because you can do this on Mac, or I think it's just on Mac, but that essentially is just an annoying feature. But then you just put, like, if I wanted to go back to 3.1, I could just put 3.1 there, press enter. And now when I load that again, I'm now using 3.1 instead. And so when you load a variable like this, it'll persist until you close the terminal, essentially. And then it'll reset to the default. If you want to keep those variables, so if I always want to use rely on 4, you can create this file in your home directory called sbgrid.conf.sbgrid.conf. And so this is a hidden file in your home directory. And essentially all you do in there, sbgrid.conf, is just put those same variables written the same way in there. So in this case, I've overridden the rely on to the newer version, and I've also overridden eman2 to a different version that I wanted to use. And so you can set this up so that every time you open sbgrid, it's just the right version that you want to use every time. And I can also do this globally. If the default version for some reason isn't great, I can just set it for everyone too. Yeah, the other way that you can load a specific version of an sbgrid program is, again, to just do this module command. So if you type module avail now you should have a bunch of, you should have a bunch of sbgrid programs down here. And you don't actually need to use the sbgrid at the beginning. You can just use the program name. So if you wanted to load one of these other programs, say I wanted to load, I don't know, this version of this program, I could just type module load, and then that program, and then it would, oh, something like that. Yeah. And then it would load the specific version so that it's using that version instead of a different one. If you're switching versions a lot, that might be useful. I tend to just put the one I want to use in that configuration file right away, so that I just don't have to worry about it ever. But and then again,
Shawn?
Yep.
Sorry, a couple additions that people may find useful. For the module avail command, I usually do prefix it with sbgrid, but you can, for example, say, you could just say module avail rely on, and it will only show you rely on versions. So,
Okay.
yeah, secondly, you can command complete those. So you can say module load sbgrid/rely on 4 and then hit tab, and it'll command complete for you and show you the options.
Right. Cool. Yeah. So now we can do all of these. And if I wanted to load like a really old version or something, we could load that version. Oops. Module. Okay. Cool. And so now that's the version that if we now started Reliant, it's going to hate me because I'm not in the right direction. So now if I start Reliant, restarts, it's now this super old version of Reliant instead of the new version. Yeah. And so, yeah, usually that's used for like, if there's a newer version, that's not the default version, like Reliant 4, which is still in beta testing. And you want to use that. That's probably the reason to do it most of the time. Cool. And so that's how to load those different variables. Yeah. So yeah, and so the SB Grid people will build the new versions of everything. I don't know, every month, every couple of weeks, and then I'll update our installation every time they do that. So it should be the newest versions that SB Grid has. The other thing is SB Grid's kind of a subscription service. So every lab that is using SB Grid should have an SB Grid license. I'm not going to monitor that, but I think most of the labs do anyway. If your lab doesn't, you should get an SB Grid license so that you can use all these and not make the SB Grid people mad. But yeah, and then the price actually goes down pretty per person or per lab that uses it. So yeah, so it's updated frequently to the newest versions of each of the open source software. And so they have the current version of every software, and then they have a few older ones. Some of the programs like Reliant you saw had like 20 different versions of it. If you need another version, I've probably already installed it because I'm just installing all of them at the moment, which takes up a lot of space, but luckily we have a lot of space to store it in, so it's not too much of a problem. If you need a program that's not part of SB Grid, so you can go on the SB Grid website and see which programs they actually support. You can just fill out a help ticket with the research computing people, and they can probably install whatever program you need for you. And they're pretty good about that. It's what they do. So, and if you also have like a problem running one of these apps, you can talk to them. Like you get a specific error message, you can fill out a help ticket, and they should be able to figure out what's going on pretty quickly. Cool. And so now,
Shawn.
Yep.
Quick question, or maybe you're going to get to this. I was wondering how you would go about running CryoSpark.
Yeah, CryoSpark's a special case, and I'll get to it in a few slides.
Okay, cool.
Yeah.
Thanks.
So yeah, so now I think John has a couple. Oh, so yeah. So now I have a couple like practical examples that are probably the cases you'll run into the most. And so running Reliant like we did before, I might actually just start a new terminal because this one's probably loading the wrong version. So the first practical example is just how to use Reliant. And Reliant allows me to control a bunch of environmental variables and make that SBatch script for you as a template. And so when you load Reliant, essentially all you have to do is navigate, start an interactive job, navigate to the directory you want, start up SB Grid, and then type Reliant. And so now it should pop up with your specific Reliant window. And the only difference from running it on your local computer versus these computers is that in this running tab, there's this option to submit to the queue. And you do want to do this. And so these are all those variables that I talked about earlier. And they're already generally, like the defaults are generally pretty good. The only difference is that maybe you want to change the number of GPUs or give it more memory for a specific task, although 40 gigs is generally a pretty good one. And then this variable here is just the actual script, the template script that this is all going to be submitted to. And so whenever you submit one of these Reliant jobs, just use this queue, and you can fill out these as you need the resources. You can also change this to preemptable. You can also change this to Blanca and preemptable. And again, that's in the slides. And then, you need to change this to 24 hours. This will just submit to a non-BioKEM node, or it might submit to a BioKEM node too, but it'll just submit to something open if you think there's going to be a long wait time or something. But again, because you're submitting to the Slurm manager, when you submit this job, it might not start right away, but it'll just sit in the queue until the resources become available, and then it will run. So don't ever worry if your job doesn't start immediately. It might just be waiting for the resources to open up, but that's a great way that shares resources. Yeah, and then I think John had a couple of things you wanted to talk about.
Okay, sure. I want to run through some simple, fairly practical examples, I think, especially for the CCET people who want to use IMOD and PEAT in fairly basic ways. So let me see if I got permission to share my screen here. Let me try. Yep, seems like it. All right, so I'll go ahead and start up an on-demand session. Can you guys see my screen okay?
Yep.
Okay.
Yep.
Apparently I can't type. First thing I want to mention is just something that you may see very rarely. These push notifications normally work just fine, but if you have an old device, old phone or tablet, or on a slow network, you may occasionally send me a push and nothing happens. It's pretty rare. Usually it just pops up a thing right away that says tap to view actions, and you can click approve and it'll say, okay, you're logged in. But what happens if you get nothing? Well, in my experience, there's a couple ways that can happen. One is if you've been off grid for a long time and you've just reconnected your phone or your tablet to the network, your Google News and your New York Times and whatever are all going to be downloading like crazy. So for the first few minutes after you reconnect, you probably won't be able to get a push through. So just don't do that. If you've just connected to the network, wait a few minutes before you try to log on. The other thing I see, I think because I'm often on fairly slow networks, is sometimes it'll pop up the notification, you'll press approve, and nothing seems to happen. Well, when that happens, look carefully, and what you'll often see is somewhere on your screen, there'll be the stylized Duo D logo. Open that, click on it, and it'll then say approve again. Or occasionally it will actually take you to the full app. And if worse comes to worse, and if nothing happens, just go ahead and open up the Duo app and click on the CU entry, and you'll be able to approve it. So this is rare, but if you find cases when things don't work automatically, that's how to work around them. Let's go ahead and go to my interactive apps tab, and you can see there are no active sessions now. Let's go ahead and launch one, and I'll just leave it at 2 hours and 2 cores, and 1 hour would be plenty. I only need a few minutes. As Shawn showed you, the first thing this does is it says starting, and it's a little counterintuitive that when it does start, all that'll happen is it's going to change to running. And the reason it does that is if they're giving you the option of changing the compression and image quality, you can turn compression down or up, and the higher compression is, the faster things will run generally. I won't mess with them. Don't turn image quality way up unless you really need it, because it'll slow things down. So we'll go ahead and launch a desktop. And just like Shawn showed you, we're going to open up a terminal, and we're going to do BioKEM Interactive. Usually this is fairly quick. We're going to want to run SPGrid software, so we'll use the SPGrid alias. And I've got some examples I want to show you out in RC Scratch. And so the first two I want to look at are for the people who are going to want to create tomograms or do subtomogram averaging with IMOD or PEAT. And I'm going to start with PEAT just because it's slightly simpler. So because we've run SPGrid, there's already a default version of IMOD loaded. And for what I want to show you, it's fine. So I'm just going to open up an eTomo project that already exists, just like you would on your own laptop or workstation. All right, and this will bring up the project. I'm not going to try to people how to use Pete today. Those of you who will be doing it already know this. And if not, I'll be happy to help you with it. But suppose we want to do a run. This is just a little tiny toy project. The first thing I want to point out is that when you go to the Run tab, there's this Use a Cluster tab. This is pretty important. If you don't do this, if I just, right now, I could go ahead and say, oh, I want to use 32 CPUs and run this project. As Shawn mentioned, when you do S Interactive, you're logged on to one of our nodes, but you really haven't allocated many resources. So if you do this, if you turn this up to 64 and press run, you might get away with it, but it's going to go ahead and you try to use the resources you've asked for, and you haven't told the resource manager that you want them. So what's likely to happen is you're likely to annoy a whole lot of people. Worst case, you can actually crash a specific node, and you'll either get voted off the island or the villagers are going to show up with pitchforks and torches looking for your head. So generally, always click this, use a cluster, and you can click either BioKEM for the nodes that we have priority on, or Blanca if you want to use even more. In this specific case, I'm going to say I want BioKEM, and I'm going to tell it to use up to 6 CPUs. And I'll just press run. What this is going to do, I'll go ahead and start this, is it'll go ahead and start a project. If you look in this directory, there's not much in the way of file now, but soon, when this thing starts up, you will see it generate, a lot of these COM scripts, and there'll be some other scripts. These are actually the scripts required to submit it to SBatch, like Shawn described. And pretty soon, once it finishes with that and realizes it's finished, it'll go ahead and start running stuff. If I do SQ right now and ask, what am I running? I'm running both the interactive thing I started up, and you can see now that it's actually queued a Pi start job, which is the first job in this application. So it's generated a batch script for you and submitted it. Depending on how busy or not the cluster is, that will finish pretty quickly, and then it'll start running things in parallel. As always, with what you're used to with iMod and Pete, you can go ahead and close this window once things have started running. And then if you come back later, you can rerun eTelmo and it'll reconnect to where it was. So you don't really need to leave that GUI open if you don't want to. But there is one thing that's different. Come on, it'll come back up eventually. And if we go to the Run tab, it'll reconnect and continue. There is one thing that's different than you're used to on your own workstation. Normally, you can not only, let me rerun SQ just at the moment, because now you'll see, I'm sorry, it's too fast. It's run 6 things in parallel and they're done. So now it's back at a sync node, which has to run alone, and you're only seeing one job. I'll try to catch it in just a minute so you can see it's queuing multiple things in parallel. What I wanted to mention is normally on your own workstations or clusters of workstations on LAN, you not only close the GUI, you can exit this terminal altogether. That's not the case here because of the nature of this interactive script. If you exit this window, everything's going to go away. So don't do that. You'll want to leave this up and running. Let's see what's running now. Yeah, okay, it's finished that sync node and it's scheduling a bunch of single core or single jobs for you in parallel. These two are just starting up, which is why they say invalid, and momentarily they'll get assigned to a node, and you can see they're all running. And this will go ahead and finish, and when it does, you can then open up the output like normal. So the important point here is for Pete, which doesn't use GPUs, remember to oh my gosh, I'm sorry. What I just did is bad. Shouldn't have done it. I did exactly what I told you not to do. what I just did is ran locally on the raw cluster. Don't do that. Click use a cluster, select BioKEM, and oh, that was when I resumed. I forgot to do it. Sorry, when I logged back in. So it was actually running correctly. But do make sure to run on a cluster for Pete so you don't get other users mad, so you're not hogging resources. So that's pretty simple. We'll let this finish and then, yeah, go ahead.
John, sorry. On the terminal window, do you ever run the screen command so that there's no kind of risk of accidentally shutting everything down? But when you
No, there is. We'll come to that later. S
Okay.
Interactive automatically runs the screen command for you.
Okay.
And so this is a screen command, and I actually think it's problematical. I think for most naive users, I would prefer not to do it, and I'll show you the reasons a little bit later.
Okay. Thanks.
So, but yes, you can use screen or tmux to do that. But even so, because of the nature of the S Interactive command, so this is actually running screen right now. If I exit this window, it'll still kill the job. What you have to do if you want to use screen the way you're describing is you have to go to a login node, start up a screen session there, and then from there connect to the node you want to run. Then you can leave that original window running. The reason leaving this window up is not a big deal. You can go ahead and close this whole window. You can actually, as long as you don't delete it, as long as you leave this running, you can log all the way out, close your browser. And then if you want to reconnect, you just go to this list of things you have that are still running and say launch core desktop, and it'll bring you back to where you were. So it's not really a big problem. It's just that it's normally we set the stuff up so you can exit freely. And this way you can't, when it gets done, just like normal, if you want to open up stuff, there's an icon you can click and it'll bring up a graphical display. And this is just a little cartoon example. So it's not going to show you much interesting. It's drag the slider. Its project is called Pi, and it's reconstructing cartoons, basically, nothing interesting. So that's a real quick introduction to how you would run Pete. iMod is similar with a couple little wrinkles. So let me go ahead and get out of here, and we'll switch to an iMod example that Eileen and Courtney and Gary, people who are going to want to reconstruct tomograms from tilt series, are going to want to know how to do. Sorry. Okay, as before, I've got a pre-existing project that I'm going to open up, tomography project. And when you want to run on CPU only, things are pretty much the same as what you just saw. Let's go ahead and for example, let's say we wanted to do the erasure step and the create align stack. Just like before, you would click use a cluster, pick BioKEM or Blanca, and tell it how many CPUs you want to use. And this will nicely allocate them, tell the resource manager how many it's using, and everything is pretty much fine here. To do this, you want the parallel processing selection here checked. If it's not clicked, it's just going to run locally on the node, and you're back in the situation where you have to have allocated the resources first, or you should have, to avoid hogging resources. There's one problem which I'll show you how to get around, which is if I go ahead and tell it like 7 nodes or something and tell it parallel processing, tell it align and build tomogram, that'll work fine. It'll go ahead and do it fairly quickly. As long as you want to run on CPUs or on a fairly large number of CPUs. So that already ran the pre-processing step, and here's the real processing. There is a problem, however, that if you want to use the GPU and you're using a cluster, you can't click use the GPU. David's going to have to change some stuff in the iMod scheduling to make that work. So that'll be available at some point. So what do you want to do? What if you really want to run on a GPU instead of running on multiple CPUs? For most people, as you see, this is fast enough that just give it enough parallel CPUs and you'll be fine. But what if you really want to use a GPU? How do you do that? That's a little more involved. Let me let this finish. Actually, no, there's no reason to let it finish. I take my word for it. Well, it did, and you could open things up now. Let me show you how you would do that if you really need specific resources. And Shawn's alluded to it already. So what you would do, I'm going to go ahead and exit. And you'll notice when I exited it, I got to this thing called SHAA. I'm not back to a node that says viz. I'm not where I started. This BioKEM interactive script that we're running goes through a couple steps to actually get you to where we need to be. So you've got to exit twice to get back to the viz node where you started. All right, now suppose we want to actually allocate resources manually. The way to do that is to SSH to a login node. As before, it'll ask you for your password, and you'll have to give it another two-factor authentication. And this time my thing popped up the full app instead of just approving it. But all right, now we're on. Once we're on the login node, remember Shawn mentioned that from login node, you can get to any of the clusters, not just ours. We want to run on Blanca. So the way you tell it that that's what you want to run on, you say module load slurm/Blanca. All right, and now instead of using BioKEM interactive, we're going to run S interactive manually. Whoops. Sorry. That one has an error in it. And what I want to show you. All right. Suppose I want to be able to, I want to allocate resources so I can run 6 things locally simultaneously, and I want 2 GPUs. For this S interactive, you'll always tell it QoS is either Blanca or Blanca BioKEM. Accounts always Blanca BioKEM. Partition is either preemptible or Blanca BioKEM. You can tell it the number of tasks. You can tell it you wanted 2 GPUs. You can tell it how much memory you want. Once we do that, oh, I'm sorry, I've mistyped there. It's gres equals GPU2. And then once that starts, now because we've told it we want one second here. Because we've told it that we're allocating those resources, now it's okay. Oh, sorry, I forgot to invoke SB grid. It's not going to like that because I can't type and talk at the same time. Because we've allocated a GPU and some resources now it's okay to go ahead and run locally. And so now we don't need to check use a cluster, and we can do both parallel processing and use the GPU and tell it we want a couple GPUs and go ahead and run. It'll run just fine. I'm not going to do it at the moment, but that's how you would do it if you really want to use GPU or a specific type of GPU. There's another problem.
Oh,
I'm sorry, go ahead.
BioKEM custom script that I made.
Yes. Actually, that's true. I'm sorry. I meant to. That's what I meant to use for this example. BioKEM custom lets you specify number of CPUs and GPUs, and that's the easy way to do this. It's much easier than this. Go to the login node. The reason, and that's what I meant to show you for this example. So what you would do if we were to back up, let me go ahead and do that. Well, actually, I won't do it. I'll type the, on the viz node, what I would do if I wanted to do that is I would use Shawn's BioKEM custom and say, oh, give me 6 CPUs and 2 GPUs. And you can do that right from the viz nodes, and it's simple. Then it's fine to run the GPU locally. That's good. What I meant to show you with this particular example where we're doing resources is a different problem that actually requires this more complicated one. And let me show you that one. So there's a problem you may run into. I've already gone ahead and generated this full tomogram, and it's a big 4K by 4K by 2K tomogram, and I've post-processed it. And so suppose I went out here and I said, show me the trimmed volume. Okay, and what'll happen, unless I got very lucky this time, typically it'll bring 3D mod, it'll start loading the slices as you see in the dialogues here, and it'll get to somewhere around 800, and then it'll crash. And this time it actually gave you a nice error message. Frequently it just crashes. What's the problem here? Why can't we read this volume we just generated? Well, here's what's going on. Let me get back out of here. And I'm back in the login on login 10 now. This is a, if you think about it, 4K by 4K by 2K is like 32 pixels, 32 billion pixels. And if they're using 2 bytes each, that would be 64 gigabytes. So we're not allocating enough memory. It doesn't have enough virtual memory address space. I'm going to tell it to allocate 32 gigabytes for this process. And then you'll be able to open it okay. And so be aware that in a lot of cases to get things to work, especially when you start working with big 3D volumes, amount of the memory allocation is something you may have to deal with.
I can
And
add
it,
to the,
sorry,
I can add that argument to the custom scripts too.
no, yeah, don't. Oh, you could, oh yeah, it would be good to adding a memory option to the custom script would be great, an optional one.
Yeah.
I don't want to, I thought about making this default to having more memory because yeah, adding it would be much nicer than people having to do this, go to slogin and use the sinteractive command. Then I'll go ahead and open this up and it'll open that volume with no problem. So yeah, I would think adding that would be a nice thing. Hopefully it'll open up fine now. I already clicked you, machine. Did you miss my mouse click? It looks like it. No, it's doing it. It's just slow. Okay. And so when this finishes, that's all for iMod and eTomo. I also want to show you a similar thing with a couple of quirks with Reliant and particularly Reliant 4. Let's just let this finish. You can also open this up with Chimera or Chimera X, or if you don't want to bother doing this, you can always just copy the file back to your local workstation and open it there. But I wanted to show people how to at least do this. So we've gone beyond the point where it runs out of memory now, and you can see that the memory was actually the limitation. And momentarily it'll pop up, hopefully. Yep, so there's the HIV VLPs that everybody uses for 3D subtomogram averaging tests. All right, so close all this stuff. Let me show you one other example, which is what happens if you want to look at Reliant for subtomogram averaging, which I've been working with, and perhaps Vignesh or some other folks have too. For this, Shawn mentioned you need Reliant 4. And I don't have it loaded by default. You can do it either by setting the Reliant X variable or by doing module avail and just loading it. And I'll go ahead and do the module avail if it's gonna come up anytime in the near future. Yeah, so we'll just do this module load relying for beta. And the format they always use is program name / version. So I'll do Reliant 4.0, and then if I hit tab, I believe it'll command complete for me. Oh, it doesn't like that. Maybe I didn't give it enough. I'll go ahead and give it the full version. Okay, and I'm not going to really actually run anything here. I'm going to open up Reliant in tomography mode on this project. And I want to show you a couple things about the run GUI that Shawn already showed you. This is actually already completed, but if I were to look at the run options here, we've discussed a bunch of them, but another one of them is memory. And when you start getting into these 3D volumes, the amount of memory you need is enormous. If you don't specify if you specify too much, your job won't ever run. If you don't specify enough, the job will probably crash and not give you a meaningful error message. So what I would recommend people do when you start doing pretty much any Reliant jobs, I mean, for smaller routine ones, you've probably got a good idea that 8 or 10 gigabytes is enough. For 3D subtomogram averaging, you're likely to need a lot more when you go to do reconstruction. Start with just one MPI, so no MPI, and a couple threads or 3 threads, a small number. See how much memory it uses and gradually increase things so you can figure out how much memory you need for things to run reliably. And one thing that will help, so this job I just ran is job 23. If you look out in that directory, so it's called reconstruct particle tomo job 023. If you look in that directory, these are like the slurm.out and .air files that Shawn mentioned before, but Reliant puts them in under the job directory for each one. If you look at the run.out file, whoops, if I could type, early on it will tell you memory required for accumulation 30. That means for each of my MPIs, it needs 30. With 2 of them, I'm going to need at least 60. And I gave it a bunch of headroom and said 80. 65 is probably cutting it too close. 70 would have probably worked. And then I told each individual job to not use more than 35 to give it a little headroom, because this is just the amount for accumulation. It's not including other stuff. So the point here is that you may have to fiddle around to figure out what settings are appropriate for a given type of job, particularly when you start doing 3D reconstruction stuff. One other thing I want to mention, sorry, does somebody have a question?
Eric's got a question.
So what I'm wondering is that given the way he's describing this, there must be a hard limit that basically wants to Blanca or BioKEM cluster the amount of memory per node that's available. And so when you set up your MPI setting,
there is, but
so each of the nodes is variable.
right, exactly.
Right. So there's not a specific hard limit per node, or like general to the whole cluster. So each node will have a different hard limit, but it's usually like, I think all of ours have 512 gigs of memory.
Okay,
so like it's a lot, but
it's a lot. It's up around 500, and you can actually allocate. I mean, you might wait in the queue a long time, but you can say, I need all the cores, I need all the memory, I need the entire node to myself. Right. So So you can do that, and they typically do have. I think they've all got more than 128 gig, and I think Shawn's right that I think the three we have all have 512, but it varies, and it'll tell you if there's not enough available.
Right.
Um,
You're not going to
one
try
other
more, but
No. One other thing I'll mention is that a lot of times you'll get into a situation where you got a warning and you realize you've done something wrong and you want to kill things. All right. People are pretty used to that in any program. And you'd be tempted to come out to Reliant and go abort running. That's great when you're running locally. When you're submitting to a queue like this, as nearly as I can tell, it does not work. So be aware that, and also the GUI will occasionally get confused. It'll tell you a job is completed when it's still running. Just don't trust abort and status in 3D jobs. Get in the habit. If you suspect something may be wrong, go ahead and go back and use that SQ job to see what you have running. And remember that you can kill stuff with S-cancel if you need to. I'll point out one other thing, although this is dangerous. Say I did this and saw that one thing had crashed, but I've got a dozen other Reliant jobs still running when I do SQ minus U, my username. You can do S-cancel minus U, your username, and that'll kill all your jobs that you've got running anywhere. It's a little heavy-handed and dangerous, but if you don't want to have to enter 12 different job IDs, it can be useful. Just be aware that this interactive session that you're in the middle of will also get killed. So this will kick you back out to the intermediate node. For myself, I made an alias called stop. We could name it something else that says, kill all of my jobs except my interactive jobs. And if people would find that useful, we could add it. It's an alias we could make available to people, but it's rare enough that I don't think it's too common. Finally, lastly, let me get out of Reliant here. Sorry, what, Shawn?
Eric has another question.
Yeah, so one last question. Since these are all interactive jobs, and you're doing it through the viz node, is there an upper limit on the time that you can run a viz node? Is it 24 hours?
I think the viz node upper limit is 24 hours, and if that gets to be a problem, they said they could change it for us.
Right.
And
So,
so
we just have a general block of time on that.
Yeah, but it's
Yeah.
generally not a problem because you're usually just submitting things to the queue. So that doesn't need to stay alive for 24 hours. You can open up a new job later
So
and
once
come
you've
back
got
to it.
everything submitted.
well, but
Yeah.
except Shawn, the place where it does matter is that in this case, my experience has been, I don't know if there's a way around it. I need to ask Andy this. What I've found is that if you go through BioKEM Interactive or S Interactive and you're logged in through a viz node, when that viz node interactive session dies and this thing gets killed, Reliant quits running too. So it does kill the Reliant job. So it is a problem when you want to run things a long time. And so in those cases, you have to either do SBatch or we'll have to figure another way around it. Now it's not that common that you do individual steps that are more than 24 hours, but there are cases, and if it gets to be a problem, we'll figure it out. There's got to be a way that we can leave stuff running. Let me mention one other thing regarding S Interactive. So if I were to get out, let me get all the way back to a viz node. Oh, and by the way, if you do manual allocation, like I just showed you, remember to log off because you've allocated those resources. Nobody else can get to them. You're basically hogging them. Make sure when you're done, or if you're going to lunch, give them up. Don't just sit there because it's keeping anybody else from using those resources. All right, on this viz node, I'm just sitting here in a shell now. I'm not in tmux or screen. And so, for example, if I do some command, I can edit things. I can do Control A to get to beginning of line, Control E to the end of line. I can use up arrow, whoops, if I do a directory listing or something, actually I can't. Oh, that's interesting. This should work. It's not acting even like a normal shell here. That's cute. Oh, because yeah. Okay, I know why. In any event, let's go ahead and do BioKEM interactive. Let me start up one of these shells, and this is actually running. You're in screen here, and there's a bunch of things that means for people who are not familiar with it. So screen is a program that lets you, it'll allow you to run multiple things at once, disconnect and reconnect, split your window into multiple panes, all kinds of stuff. But one of the problems with screen, or feature, depending on how you use it, is that its prefix for doing special stuff is Control A. So like if I were to start to enter some command and then hit Control A to go to the beginning of line, it doesn't work. To get to the beginning of the line, I've got to do Control A, and then it'll go to the beginning of the line. The way it doesn't, the other thing I can do is if I've got a lot of stuff, that's not a whole bunch of output, but suppose I had a whole bunch of outputs and I wanted to scroll up through it. Maybe you had output from a program. If you wanted to scroll, you can't just hit up arrow to scroll through your output like you're used to, because screen is catching it. To be able to scroll, you have to hit Control A, left bracket, and now up arrow works. Before, it would have just scrolled through command history, and once you're done scrolling, you can hit escape. Personally, and then you're back to normal. Personally, I think for most people who are not experts, I think being in screen is a bad thing. I think it's more confusing. If you want to see what commands are available, you can hit Control A, question mark, and here's some of the many things you can do. There's pages and pages and pages of commands. But the thing you got to be careful about is if you accidentally hit Control A and some letter, you probably just executed a command. And if you accidentally hit Control D, it will kick you, it'll disconnect screen. And for some reason, the way S Interactive works, unlike normal screen, it backs you all the way out and you can't get back in. So because of that, I think S Interactive is bad, and eventually I'm going to try to get them to give us another way of doing things so that we can change BioKEM interactive or make a new command. So it just takes you to a simple shell window and things behave more like you're used to. And that's all the tips and comments I had, unless anybody has any questions. Okay, I'll turn it back over to you, Shawn, if you want to do some more exercises. All right, I actually don't know what you've got planned for the rest of the time.
I just got a few more examples here. So we talked about those IMOD examples. Another one that I've been using a little bit, and there might be other programs like this. This is just kind of an example program. eman2 doesn't really have a way to submit things to the cluster, but what it will do is give you the actual command it's about to run. And so then you can just like write an SBatch script to submit that job for you. Or you can run it interactively, again, using this BioKEM custom command where you specify the number of CPUs you want and then the number of GPUs. And then you just have to keep that terminal open until the job is complete. And I've got a couple of example scripts particularly for eman2 here in our projects directory there, where you can just swap out your variables for my variables, essentially copy the script and then submit those things. And there might be other programs like that too. So if your program gives you an output of what it's going to do, you can always write the SBatch script yourself and then submit it to the queue, or just run it interactively. And then the other thing a lot of you want probably is CryoSpark. And CryoSpark's, for various reasons, really complicated to set up on clusters, and this cluster in particular. I have a solution. I'm still working out the kinks, but essentially what you would do is go into your window again, and I think I've got this command I might not have alias, is you just type this command that I'll give you, which is probably just going to be CryoSpark, and then your particular lab. And what it should do is open up this browser window and point you to the specific job that you, or the specific GUI that your lab needs. And there's a bunch of stuff going on under that that makes this complicated as to why it's not working at the moment. But I have it working outside of this a little bit in this. Yeah. But anyway, once it does work, the only difference that you'll see at least is that instead of just submitting it to the local computer, you'll have this option to queue to lane, and you'll just pick one of the lanes I've set up. These are just some that I'm trying out to set it on a particular node or something, but it'll probably just be either BioKEM or Blanca. But essentially, I just need to work out some security issues with the research computing people, and then we'll have to build a specific build for each lab because of the way CryoSpark is set up. But so CryoSpark does kind of work, and the only difference, once I set it up for your lab, the only difference that you're going to have to deal with is just submit it to the right queue, and it will be pretty obvious which queue to submit to. So that'll probably take a few weeks still, but we'll get there. Yeah, and then other examples, if you need to use like a visualization software, there are a few installed under SBGrid, like Chimera or Chimera X or VMD, and you can just use those on one of the compute nodes. The graphics should be forwarded from if you're using one of the interactive jobs, so that should work just fine. If you want to use VMD, you need to allocate a GPU because it's really heavy on GPUs, and a GPU allocation will make any of these programs, visualization programs, faster. So that's a good one. The other, probably the best way to do this, there seems to be a problem with it at the moment, but I think they can fix it pretty quickly, is research computing has installed a separate copy of Chimera X in their software stack that you can actually use on the Viz node. And so the graphics don't have to be forwarded anywhere. And so that's much faster and probably the way you want to do it. And they just need to install a dependency or something, I think, to get that to work again. But essentially then you just module load Chimera X from their software stack and then use that. Yeah, so in summary, this is kind of the workflow that you'll go through. From your local computer, you'll get onto one of these clusters using Open on Demand. And then once you're on these clusters, you can run one of those interactive scripts to get onto Blanca. And from there, you can submit jobs through SBGrid or through another way, through Slurm, onto any of these different clusters. And in theory, SBGrid will only work on Blanca, but if you have other software that's installed or you're using research computing software, you can also run stuff on Summit or Alpine. And to do that, you just have to log into the login node, and then instead of loading that Slurm module for Blanca, you would load one for Summit or Alpine. And I actually have a command like the BioKEM or Blanca ones that'll take you to Alpine instead. But the SBGrid stuff won't work on there for various reasons, but you can compute on there if you have other stuff that you want to compute on there. And then getting your data back, again, you can just use one of those copy commands or rsyncs back to your local terminal, or you can use like a Globus or something to get back to whatever you need. So yeah, so you really don't need too many commands. I know there was a lot of stuff, but really you just need to open up Open on Demand, start an interactive job, type SVGrid, and then just run it like normal. And then if you want to submit stuff as a script, just use the sbatch and then submit the script to do that. And if you need help, I've tried to write this documentation page that will hopefully run you through everything pretty well. If it's not on there, I would try Research Computing's documentation page because they've got a pretty good, pretty detailed documentation page. And then if you really need some actual person to help you, you can submit a ticket to the research help ticketing system, and they usually get back to me within like a couple of hours. So it's really quick and they're really helpful. And I mean, this is what they do all day long. So they understand what the problems are and how to fix them really quickly. So that's good. And then you can also go to any of the, if you have a specific program type question, go to the documentation. That'll usually get you through there. And then again, they're also good, like YouTube videos. SB Grid has I think it's weekly or bi-weekly or something. They'll have a YouTube seminar with each of the developers of any of these programs. And so if you want to learn how to use specific features in each of these, go to the SB Grid YouTube channel and watch the specific one you want, and you'll get all the cool trips, the cool tips for it. And then there are also a bunch of Google forums if you can't figure it out there. Yeah, and so that's what I have. Give it a try. If you really get stuck, let me know. I can try to help you. It should be pretty straightforward, although I'm sure you can find a way to break it pretty quickly. So yeah. And then as far as CryoSpark goes, once I work out the security issues, I should be able to get each of your labs your own CryoSpark set up in a couple of weeks. So, yeah.
Let me add one more thing too before we do questions. That for those of you, I mean, I think most people will not, actually two things. Most people probably won't do this, but if you wind up wanting to write your own SBatch scripts for an application that doesn't have a GUI, SBatch and SRun all take the same arguments for the most part, and they're good man pages for them on the web. So they're a little intimidating because they have so many options. There's probably, I don't know, maybe 100 options available for SRun and SBatch, but any one of them can go in one of those SBatch directives that Shawn showed you. The other thing to keep in mind, if you have guests or people, we've been dealing mostly with BioKEM Blanca because supposedly all of us have access to it. But as Shawn mentioned, it's a condo model, so it's only available for people who've bought into it by buying a node. Summit and Alpine, however, are NSF supported. So people who have not bought into the cluster can still run stuff in the RC stack or compile their own software on Summit and Blanca. And much of what we've described applies to those too.
Yeah. Yeah. Cool. Does anybody else have any questions about how to do this? I think you probably just have to try it and see if you get stuck, essentially. But yeah. Cool. Thanks for coming.